So, hello, dear students. Here we are for JEE Bytes to discuss about electromagnetic waves. So, this chapter is particularly for JEE mains. In JEE Advanced, this chapter is not there. So, hello, everyone. Hello, Apur, Meghna. Good evening. So, yes, dear students. Again, as you all know, this is also a chapter of class 12th, electromagnetic waves. So, good evening, Apur, Abhinav, Ramesh, everyone, good evening. So, in the first chapter, you have learned that a charge, an electric charge, at rest, it produces electric field around it, right? Or you can say electrostatic field. Second, in other chapter of magnetism, we have learned that charge in uniform motion creates magnetic field. Charge in uniform motion creates magnetic field. And today we are talking about electromagnetic waves. When a charge is accelerated, when a charge is accelerated, it creates electromagnetic field, or we can say electromagnetic waves. Accelerated motion creates electromagnetic waves. So earlier you have learnt about electromagnetic induction. So what was that? We had learned that by the change of electric, by the change of magnetic flux, electric field was induced. So the reverse phenomena, that means by change of electric field, magnetic field is also induced. So this was a discovery of various scientists like Maxwell, and they actually you know gave a model of electromagnetic wave. An electromagnetic wave, if you talk about electromagnetic wave particularly is a transverse wave. Transverse wave means, so here, see, as you have learned earlier about mechanical waves, in mechanical waves, the particles they oscillate. Particles they oscillate. If it's a transverse wave, the particles they oscillate in the direction perpendicular to the direction of propagation. In electromagnetic waves, in electromagnetic waves, electric and magnetic field they oscillate in the direction perpendicular to the direction of propagation. So, if you want to find the direction of propagation, you should use this E cross B. E cross B tells you the direction of propagation. Always remember this formula. Now, We will see some questions of previous year JEE. Okay, students. So, an electromagnetic wave from air enters a medium. The electric fields are E1, E01 x cap cos 2 pi nu z by c minus t in air, and E2 vector is equal to E02 x cap k2z minus ct. Yes, it's a question of JEE 2018, where the wave number k and frequency nu refer to their values in air. Okay, the medium in is non-magnetic. The medium is non-magnetic if epsilon r1 and epsilon r2 refer to relative permittivities of air and medium respectively. Which of the following options is correct? That's the question. Firstly, we will understand what is the equation of electromagnetic wave. If you talk particularly about electromagnetic wave, its equation is represented by this. Suppose E, let's say, is in y direction, and the direction propagation is along x. So we write Ey is equal to E naught times sine kx minus omega t. So here, if you see this equation, here the electromagnetic wave is moving in z direction and it's oscillating in x direction. Yes. So yes. So this is the formula. It can be the sine function, it can be cos function, right? So here it's given that it can also be cos function. Okay. So cos of kx minus omega t. Wait. Cos of kx minus omega t. Generally, the equation is a sinusoidal type, so it can be cos, it can be sine. So yes, now observe this. E1 is equal to E01 x cap cos 2 pi nu z by c minus t. So let's say first one, E1, that means in air. In air. In air, E1 vector, or let us say we talk about magnitude only, magnitude. So E01 cos of 2 pi nu z upon c minus t. Okay. So now do one thing. Simplify this equation and convert it to the form that is kx minus omega t. So 2 pi nu by c z minus 2 pi nu into t. This is the equation of electromagnetic wave in the air. Okay, fine. Now talking about the other equation in the medium, in given medium. In the given medium, E2 is equal to E02 cos of 2kz minus 2k ct, right? Now, from the given equations, what we can say that for the first equation, you can understand that this is the value of the wave number, 2 pi nu by c. And for the second equation, or for the medium, the given medium, this is the value of k, the wave number. Okay. So yes, now writing this again. Yes. So for air, K is equal to 2 pi nu by C. Okay. And for the given medium, K dash is equal to twice of K. So dear students, try to understand that even though even though what happened? Okay, okay, yes. It should be a KCT only. Yeah, fine. Yes. Even though the medium is changed, the frequency doesn't change. Velocity may change, but frequency doesn't change. Right? Frequency remains same. Okay. So writing this K dash in terms of frequency. So 2 pi nu divided by C dash, where C dash is the velocity of the electromagnetic wave in the medium. Okay. Now, this means C, this means C is the speed of electromagnetic wave in the air. Now we can find the value of C dash in terms of C. C is equal to 2 pi nu by K. And for the second equation, you can understand that C dash is equal to 2 pi nu by 2K. This implies if you compare these two values, you can understand that C dash is equal to C by 2. C dash is equal to C by 2. Okay. So what does it mean? C dash equal to C by 2. Okay. So this means the velocity has, velocity has become half. So yes, what is the formula for velocity of electromagnetic wave? We have learned that velocity of electromagnetic wave in a given medium is given by this formula. Under root of mu times epsilon. Or we can elaborate it like this. Mu naught, mu r1 and epsilon naught, epsilon r1. Okay. So comparing for the two media, given that epsilon r2, epsilon r1 and epsilon r2 refer to relative permittivities of air and medium respectively. So that means what we can say, see, C dash is equal to C by 2. Okay. So now writing C dash. C dash means for the medium 2. Under root of mu naught, mu r1, epsilon naught, epsilon r1 is equal to 1 by 2 times 1 by under root mu naught, okay, sorry, it should be mu r2, epsilon r2, because we have taken medium, for medium we have taken 2. So mu r1 and epsilon 0, epsilon r1. And it's given the question that the medium is non-magnetic. So this means mu r1 and mu r2 are same. Because the medium is non-magnetic. So what we can do, we can cancel out some things. Mu naught can be cancelled out. Epsilon naught can be cancelled out. Mu r1 and mu r2 can be cancelled out easily. So what do we get? We get under root of epsilon r1 and epsilon r2 is equal to 1 by 2. Or if you square both sides, you'll get epsilon r1 by epsilon r2 is equal to 1 by 4. This is the answer for the first question. That means A is the correct option for the given question. I hope all of you are able to understand that. Let's move forward now. Arrange the following electromagnetic radiations per quantum in order of increasing energy. Now, students, if you have learned photoelectric effect, in photoelectric effect, you must have learned that E is equal to H nu. Okay, this is what? This is the energy of a photon or energy per quantum. So we have to compare the frequencies of the given waves. Okay, so let me tell you one very easy way to remember all the electromagnetic waves. CG, X, U, V, I, M, R. Remember like this. C for cosmic, G for gamma, X for X-ray, U for ultraviolet, V for visible range, I for infrared, M for microwave, R for radio wave. Okay. If you go right, lambda increases. If you go left, frequency increases. So you can remember like this. It's a very easy way. So in any way you can recall all of them just by learning this simple mnemonic CG, XU, VIMR. Okay, yes, now what is the question? We have to arrange them in increasing order of the energy or in increasing order of their, you can say, the frequency. So we have to arrange them in increasing order of their frequency, right? So yes, so these two are in visible range, X-ray and radio wave. Radio wave has a least frequency, so D first, and yes, X-ray has the maximum in the given case. So yes, C. Now blue and yellow. If you write visible, the spectrum of visible range is given as V increases. If you go left, mu increases, right? So in a given question, yellow and blue are given. So obviously, blue is having more frequency. So yes, the correct answer will be what? DBAC. Because yellow has less frequency as compared to blue. So the correct answer for the given question is D. D is the correct answer for the given question. Let's move forward now to next question. This question is based on the uses. So you have to remember them. Okay, so this one is a very simple question. Match list 1 electromagnetic wave type with list 2 its association application and select the correct option from the choices given below. So yes, very common thing. Radio waves are used for broadcasting. That's very well you know. Ultraviolet rays are absorbed by ozone layer. You very well know. X-ray are used to detect the fracture of the bones. So that's also known. And infrared waves are used to treat muscular strain, right? So this is the correct match, and find the correct match in the given options. So yes, A first, B second, C okay, A first, B second, C third, and D fourth. So B is the correct answer for the given question. So yeah, I hope it's clear to all of you. Let's move forward. Now, the magnetic field in a traveling electromagnetic wave has a strength of 20 nanotesla. The peak value of electric field strength is, we have to find the peak value of electric field strength. So yes, all of you know, all of you know that C is equal to E naught by B naught, right? C is equal to E naught by B naught. So E naught is equal to B naught into C. So just by that formula, you can find the value of E naught. So B is equal to 20 nanotesla. That means 20 into 10 raised to power minus 9. And C is 3 into 10 raised to power 8. So multiply them and you get the answer to be 6 volt per meter. The correct answer is B. Let's move to the next question. Okay, sorry. So thank you so much, students, for being here. So I hope you learned a lot today. So to know more how we can help you in your preparation of JEE, you can see the given link, and the link is mentioned in the description below. So thank you so much, all of you.